We are continuing with Chapter 2, Section 2.3, which deals with changes in market equilibrium. So let's review what happens when we have changes in market equilibrium. Supply and demand curve shift in response to changes in other variables other than price. The market results in equilibrium where the quantity supplied is equal to the quantity demanded. In figure 2.4, we have a shift of the supply curve to the right. So we can see that the supply curve shifts to the right due to that arrow over there. So originally, equilibrium occurred with the intersection of the old supply and demand curve with a price P1 and a quantity Q1. But let's say wages have declined, and as a result, the costs of production are now lower, and that results in a shift of the supply curve to the right. As a result of the lower production costs and your supply curve shifting to the right, we now have the market clearing at a lower price P3 and a larger quantity Q3. So this is an example of the supply curve shifting. Figure 2.5 shows a rightward shift of the demand curve. In the previous example we dealt with a scenario of income increasing and that being the reason for the rightward shift in the demand curve. But let's try another example. Let's say consumers change their taste or preferences from normal sugar to xylitol sugar because of the perceived health effects. And as a result of that, we see an increase in the demand for xylitol sugar and the curve shifts to the right. As a result of the rapid shift in the demand curve, consumers will now pay a higher price P3 than before, but there will also be a large quantity produced at Q3. This is us comparing that against the original equilibrium position. So just to recap, as a result of a change in the taste or preferences of consumers to a new product of sugar, we now have a shift to the right for that particular product, and as a result, consumers pay a higher price, but the quantity produced by our producers is also greater. However, in many cases, we find that both demand and supply may shift, and this is what figure 2.6 shows us. It demonstrates how we can trace out the effects by two curves shifting simultaneously. So there we have our supply curve shifting to the right, and we also have our demand curve shifting to the right. And we can see the net effect of that is a slightly higher price, but also a much larger change in the quantity. We are now comparing the old equilibrium point to the new one, where we have the intersection of the new demand and new supply curve. So in general, there will be changes in the price and the quantity when both curves change. However, the magnitude of the shifts of the curves as well as the direction of the shift will impact to what degree the price changes as well as to what degree the quantity also changes. The following slides, from slides 13 to 18, provide examples which you may work through to consolidate your understanding. I will not be working through these. I will expect you to work through these subsequent examples. So I'm going to pause and then skip forward through to slide 19. We continue with the next section, section 2.4, which deals with elasticities of supply and demand. Now, very often we want to know how responsive the quantity supplied or quantity demand is to a change in the price or to any other variable that may affect demand or supply. Demand for a good depends on not only its price, but also the prices of related goods and income. Supply, on the other hand, of a good depends on not only its price, but also the costs of production. So elasticity helps us to answer the question of how sensitive or responsive one variable is to another. More specifically, it is a number that tells us the percentage change in one variable resulting from a 1% increase in another. Let's begin with the price elasticity of demand. It is defined as the percentage change in the quantity demanded of a good resulting from a 1% increase in its price. And here we have the formula given. We have the percentage change, that delta means change in the quantity demanded for a given percentage change in price. This can be expanded to the formula here that we have in 2.1. And ultimately what you worked with when you worked out the point price elasticity of demand, you would have the price over the quantity times the change in the quantity over the change in price. Now, the price elasticity of demand is usually negative, thus the change in Q over the change in price is negative. We know that if the price of a good goes up, the quantity demanded would fall. The magnitude of the price elasticity of demand, or the absolute size, is that value that we interpret. And we also know that if the price elasticity of demand is greater than 1, we say it is elastic. And if the price elasticity of demand is less than 1, it would be inelastic. So we have a linear demand curve, and we know that linear means straight line. So the demand curve is a straight line of this particular form. Q is equal to A minus B. For a straight line, the slope is constant. However, we know that elasticity varies all along the curve as price and quantity change. So there you have a general function for this linear demand curve. Q is equal to 8 minus 2p. So we know that the slope would remain constant throughout. However, the elasticity would vary all along the curve. At the topmost point over there, we have our price elasticity of demand. It is high because the quantity is small, so the elasticity is large in magnitude. And here we have perfect elastic demand, and it is equal to infinity. Then over here we would have our unitary point price elasticity of demand, and here our point price elasticity of demand is equal to 0. So as we move along our linear demand curve, the elasticity coefficient becomes smaller to the point where it is perfectly inelastic. Between this range, where it is smaller than 1 but greater than 0, it would be inelastic. And between this range over here, where it is greater than 1 but less than infinity, we would say that it is elastic. Apologies for that. Right. So the price elasticity of demand is measured at a point. Because demand and supply curves are drawn with price on the vertical axis and your quantity on the horizontal axis, we find that the change in Q over the change in P, which is part of the formula, is in fact 1 over the slope of the curve. Right, so that is important to note when we do certain applications in section 2.6. Right, so in figure 2.12, we have a scenario where the figure demonstrates an infinitely elastic demand curve. Now for a horizontal demand curve, the change in Q over the change in P is infinite. So even the slightest change in price will lead to a drastic change in demand because the elasticity of demand is infinite. So if price increases by even a bit, the demand will fall to zero. So the principle of infinitely elastic demand, it is the principle that consumers will buy as much of a good as they can get. You can see that at a single price, but for any higher price, the quantity demanded will fall to zero, while for any lower price, the quantity demanded will increase without limit. Another scenario to consider is a completely inelastic demand curve. And here we have an completely inelastic demand curve, and you can see that it is in fact a vertical curve. And here the change in Q over change in P is zero. So what is this principle all about? Well, the principle states that the consumer will buy a fixed quantity regardless of the price. So because the quantity demanded is the same, no matter what the price, the elasticity of demand, EP, is equal to zero. Other demand elasticities were also covered in depth in your ECO231 module in your first year. So your income elasticity of demand can be explained as the percentage change in the quantity demanded resulting from a 1% increase in income. Thus, the I represents income and the Q represents your quantity demanded. And this is typically the formula that you would use. In terms of the interpretation of the elasticity coefficient, it would help us to distinguish whether a good is a luxury good, a normal or inferior good, depending on the sign and the size of the coefficient. Another demand elasticity that you encountered is the cross-price elasticity of demand, and that is where we look at goods that are related, such as your substitutes and your complements. And here it is defined as the percentage change in the quantity demanded of one good, resulting from a 1% increase in the price of another good. In this example, the B represents butter and the M represents the price of margarine. So this is a way of demonstrating how you can use it to calculate the cross-price elasticity of butter and margarine, two substitute goods. Right. Lastly, you also looked at the elasticities of supply. The price elasticity of supply can be defined as the percentage change in the quantity supplied from a 1% increase in price. Now, your elasticity of supply is usually positive, and the formula is similar to that of your price elasticity of demand. And once again, you would interpret the values in terms of those categories. Is it elastic, inelastic, perfectly inelastic, perfectly elastic, or unitary, based on the magnitude of the coefficient. The final point of discussion is to consider when to look at point versus arc elasticities. Now, point elasticity of demand is calculating price elasticity at a particular point on the demand curve, whereas your arc elasticity of demand is useful when you need to calculate over a range of prices. So in that case, instead of choosing either the initial or the final price, you would use the average of the two. And arc elasticities lie somewhere between the point elasticities. And this is the formula that you would use for your arc elasticity of demand. So the following two slides, slide 25 and 26, presents a example. It is fairly straightforward again. So work through the example where you have to calculate the equilibrium price and quantity, as well as the price elasticity of supply, as well as your price elasticity of demand, to consolidate your knowledge. Thank you.